Sequence abstraction. So this is a thing you actually know by now, and you used it. So all we have to do is just to say it and to make it explicit. So you know different kinds of collection data structures: lists, vectors, hash maps, hash sets. Okay, but all of them can be, they are rather different, but all of them can be handled as a sequence. So no matter what kind of collection data structure you have, you can actually just go through it as a sequence. Okay, that's the idea of sequence abstraction. So let me show you how this works. So there is this function called seek that whatever data structure you give it to, for example, I have this list, and it turns it into a sequence. Well, okay, that's a list. It's already just a sequence. List is just a sequence. All you can do is just go through the elements one after the other. But what happens if you seek a vector? Okay, well then it sequence is just a list, so it will look like as a list. Of course, you have a string as well. Okay, so you can go through the elements. Well, yeah, sure. It's JavaScript handles the characters seemingly as one character string. So yeah, but anyway, you have the pieces, and you can go through as a list. So now it's like you want to seek like yeah, here's a hash set. Okay, 1, 2, 3, 4. Okay, so that turns it into a sequence. However, you know, one has to be careful because it turns it into a sequence. But let's say if I have a set, okay, I'm making a hash set of 100 numbers. Well, that's okay, maybe that's too much. 20 numbers. Okay, that still comes out as it's still in order. Anyway, let's try to make it bigger then. Okay, here you go. You see, it's like it's not guaranteed that they will be in the original order you write the elements. Okay, that's what a hash set does. It doesn't promise you to keep. It's not a sequence. It's just a bag, really, just a mathematical set notion. Okay, so although when we generate the set, we give the elements in order, that is gone. Another interesting thing is that what happens if you take the seek of a hash map. Well, that gives you a sequence of the elements. An element of a hash map is a pair, a key value pair stored in a vector. Okay, so you still get a sequence, but the elements are, well, the elements of the hash maps. So that's something to keep in mind as well. So what's the benefit? The benefit is that you know, you can use sequence functions like, well, you know, first and rest, and even the functional collection processing like the map, filter, and remove. Okay, it's all work with all the data structures. So let's say if I want to map second on what? Well, let's have this hash map. So what do I get? Well, this is actually the values. Okay, So map, although you don't see the seek in this one, but map will actually ask for a seek. So it gets a collection, here's a hash map, and it will implicitly seek that. And after that you will have this, and it's like this is one element, and you apply the function second while you get the value. Okay, if you do first, okay, then you get the keys. So we just re-implemented keys and values, okay, with using map. So what's the benefit? Well, for students, that means that you don't have to learn a lot. So once you learn first, rest, map, filter, remove, you can use it for any data structure, any fundamental data structure. Okay, so that's it's not that as in order to go through the elements of hash map you have to do something else. Well, you just do the same thing. And of course, it's not just for a student's benefit. This allows us to do code reuse. Okay, so we write a code that go through the elements. Then it doesn't matter if we actually use a different underlying collection. We can switch the collection to a different representation. So this is very nice, and this is the sequence abstraction.